Chapter 2, Section 5 deals with transformations. What does the word transform mean? Changes, yeah. When you transform something, you change it. How many changes can we make to functions? Not really. There's only it seems, but it's really 6. We have 6 changes we can make. Oh, okay. 7 changes. I didn't think about that one. Yes, but you're right. Yes. The first change we can do, we have 7 changes. We can do a horizontal shift. That's left and right. We could do a vertical shift. That's up and down. We can do what's called a reflection. And there's actually 2 of those. Horizontal reflection, which is we rotate it about the y-axis. We have a vertical reflection where we rotate about the x-axis. We have horizontal stretch or shrink, which is and the horizontal stretch. It's where we push the graph together or we pull the graph apart horizontally. And then we have the vertical changes. Compression, it's where we push down on it from both sides, make it shorter, and stretch or expansion. It's where we push it, pull it up and down. Well, if you look at it this way, it's only 5. But there's really the horizontal, vertical, stretch, shrink. So these are, okay, we'll go to 5 then. But yeah, these are the what we can do. We could shrink the graph, we could stretch it, we can pull it up, we can slow it down, we could move it to the left, move it to the right, up and down, whatever. The first 3 of these are super easy. It all goes into our function. each of these things are a result of A, B, C, or D. The first one we're going to look at, we're going to say that A equals 1, B equals 1, and D equals 0. So all we're going to look at is this. The C value could be positive or negative. These are the horizontal shifts. If we have X plus some number C, we shift left C units. If we have X minus C, we shift right C units. Again, now these transformations, I cannot stress enough how important it is that you memorize the library of functions. For example, graph this function. The way you graph it is the first thing you have to do. Here are the steps. Identify the basic function. So in this example, what is the basic function from the library of functions? One over x squared. Because you have one on top, the x is on the bottom, and it's squared. Forget about the plus 2 right now. So that's, what does the 1 over x squared look like? What does it look like? I'm glad you all took all that time to memorize it. It's the Atari. Again, memorize these things. So that's the first thing you have to do. Second is look for the horizontal shift. In other words, the horizontal shift occurs inside the function. Horizontal shifts affect the x value first before you do the operation. In other words, what do you do first? If I give you a value for x, what do you do first? You have to add 2 to it and then square it. So this is the shift. Which direction does it move? And how many spaces? Why? Yes. Now, here's the reason why. Yeah, I'm glad you remember from the previous page. Because the original graph had the origin at 0, 0. Now, this one, I take what's inside the parentheses, set it equal to 0. I want to see how far where I moved it. So I solve it. I get my x is now at -2. So there is my new origin. If it's inside the parentheses, it's a horizontal shift. In other words, if it affects x first, then the graph looks the same. And there's your graph. Example 2. Graph this one. First, what's the original function? What's the basic function of this equation? Absolute value of x. What does that graph look like? It's a v. Very good. From the origin. Since we're inside the function, that means it's a horizontal shift. So we set the inside equal to 0, and we see that it shifts to the right 3 spaces. The new origin is at 3. The graph looks the same there. So there's the graph. So if there is a change inside the function, affecting x first, then it is a horizontal shift. In other words, if we have x plus or minus some number, before you do the function, the operation of the function. So that was this kind of change. If it happens inside the function and affects x, you have to change x first before you take the square, the absolute value, whatever. All right. The next one we're going to look at are vertical shifts. Vertical shifts occur outside the function. In other words, you have to pick an x value, plug it in there, whatever your answer is, then you do the vertical shift. Remember, horizontal shifts are always opposite. Vertical shift, if D is positive, it shifts up. If D is negative, it shifts down. For the vertical shift, it is what it is. If it's positive, you shift it up. If it's negative, you shift down. Like this example. What's the basic function? Look at where the x is. What's the basic function? 1 over x. What does the graph of 1 over x look like? Because it's not exponent squared, it's an odd exponent. Positives are positive, negatives are negative. Is there a horizontal shift? No, because nothing affects the x. So now what we do is we subtract 3. We take this graph and lower it 3 spaces. This is my new origin. The graph looks the same. It's just shifted down 3 spaces. How about that one? What's the basic function? The cube root of x. What does that graph look like? All right, it's the elongated S. Is there a horizontal shift? Is there anything added to x from respect to x? No. So there's no horizontal shift. There's an outside number. So we do a vertical shift up 2 spaces. So my new origin shifts up 2 spaces. So the graph looks the same. It's just when you do this for homework, you have to plot some points so you get some accurate coordinates. But I'm just showing you where the origin shifts to. Okay, let's combine those two. sketch that graph. First, what's the basic function? 1 over x. That graph looks like this. So we know what our final graph has to look like. The next is their horizontal shift. Yes, since it happens inside the function, there's a horizontal. Which direction? How many spaces? To the right, 2. Because if you ever forget, take whatever you have there, set it equal to 0. That's my new 0. So there's my new origin. So the graph looks the same there. So then lastly, we have a vertical shift. We go up 3. So we go to 2 and we go up 3. 1, 2, 3. So my new origin shifted to there. So the graph looks the same. And again, you just have to plot some points. And once you get that, then it's okay. So far, so good? So those are horizontal and vertical shifts. Now let's look at reflections. A f of bx. All we're looking at, A and B, only thing we're looking at is A positive or is A negative? Is B positive or is B negative? That's all. We're not looking for values, any numbers just yet. We're just looking for signs. So our first reflection, let's look at horizontal reflection. Where do horizontal changes occur? Where in a function does a horizontal change happen? Inside the function, yeah, to the x. It affects x. So horizontal reflection change, it's x changes sign. The way you look at this one is you have to first, the basic function is 1 over x. Which looks like this. The second thing you have to look at is the horizontal shift. So we have negative x plus 2 equals 0. X equals 2. So it shifts to the right 2 spaces. But the value of x changes signs. Which means that the graph has to rotate about the y-axis. So now we have this graph. With another one. Sketch that one. All right, what's the basic function? Radical x. What does that look like? Right. From the origin, it swoops out that way. Then what happens to the function? Then x has a negative in front of it. Since x changed signs, that means I flip across the y-axis. Let's think about it. What's the rule about, what are the two rules about radicals? Or one rule. What can you not have inside radicals? Square roots. You cannot have negatives. So the only way we can get rid of this negative is if x is negative. So that's why it has to go backwards. And then lastly, we have 2 minus x. So which direction, how many places do we shift? It moves to the right 2 spaces. Because again, you take what's inside there, set it equal to 0. X, our new 0 is at 2.
It would be +2.
It is +2.
If it was +2, would it go?
No, because there's a difference between that and that. You still, if you set them both equal to 0, what happens? This one equals 2, this one equals 2. So that's what I'm saying is if you ever have any doubts, take whatever's inside the function, set it equal to 0, and then find out where your new 0 point is. How about this one? What do we notice about the absolute value symbol? Is it an odd or an even function? In other words, do we rotate it about the x-axis or the y-axis? It's rotated about the y-axis. It's the same value on both sides. So when we rotate it, we get the same value. We get the same graph. So our basic graph is absolute value of x. When I change the sign of x and I rotate it about the y-axis, I get the same graph because it's an even function. Is there a horizontal shift? How many spaces, which direction? Yeah, because 3 minus x equals 0, so 3 equals x. So it's 3 spaces to the right. So there's my new graph. Is there a vertical shift? I go up 2 from that point. So I go 3 to the right and up 2. So there's my new origin and there's my new graph. So that's reflections about the y-axis. Now let's look at reflections about the x-axis. They call these vertical reflections. If they're vertical, it's about the x-axis. Here, the y changes sign. So this one is the a function. If the coefficient, if a is positive, nothing changes. But if a is negative, it flips across the x-axis. F of x equals negative square root of x plus 2. Again, we go through the whole sequence of questions. Basic function. What's the basic function? Square root of x. And that looks like this. Is there a horizontal reflection? Or does x change signs? No. So is there a horizontal shift? Yes. Which direction does it shift? And how many spaces? To the left, 2 spaces. The graph looks the same. Is there a vertical shift? No, because there's no constant number. This is a vertical reflection. This is a vertical reflection because now the whole graph flips over the x-axis. So it goes to the left, and this time it goes like this. It flips over the x-axis. Any questions about those? Because if you do a horizontal and a vertical flip, you can get to the original equation on odd functions. So let's do another example. Then we'll move on to the last part. Basic function, 1 over x, right? And that looks like this. Is there a horizontal reflection? Does x change signs? No. So is there a horizontal shift? It shifts 2 to the right. So the graph looks like this. Is there a vertical flip reflection? Yeah, because the whole function is now negative. So what does that mean? It flips across the x-axis. That's all with the function. Now we could do a vertical shift. The vertical shift comes last because it's just a number. So we have negative 1 x minus 2. We go down 3. So we go over 2 and down 3. The graph will look something like this. So that's if the coefficients of the function and the coefficient of x, if they're just signs. If the coefficients are numbers, so if a and b are numbers, so if b is greater than 1, again, if it happens inside, what is it? Is a horizontal or vertical? It's a horizontal. Anything happens inside the function is horizontal. Because if it happens inside the function, if c makes it go left and right. If it b is a negative or positive, it flips across the y-axis, which is horizontal. So if b is greater than 1, then we have a horizontal change. Remember, also another thing, for inside the function, if it was x plus 2, where would it shift? Left or right? So if it's x minus 2, it shifts right. So whatever happens inside the function is always opposite. So if we had f of x equals 1 over 2x. Since our b value is bigger than 1, this is a horizontal shrink. If b is greater than 1, then we have a horizontal shrink. Which means our function changes like this. If our function changes then our X and Y values that's what changes. Because it's the opposite of what happens inside. Instead of multiplying the values of X to get a bigger X, we divide by X because it shrinks it. If B is between 0 and 1, then it's a horizontal stretch. And again, it's the same thing, but if you think about what happens here, if B is a fraction, if we had X over 1/2, what does that become? You have a fraction on top, fraction on the bottom, so you flip it. It actually doubles it. So that's why it's a stretch. It makes it wider. So if you have a coefficient in front of X, if it's greater than 1, that means it gets shrunk. If it's a fraction, then it's a stretch. Now, A, if it's outside the function, it is what it is. If A is bigger than 1, then it's a vertical, because anything happens outside is vertical. It's a vertical stretch. Why is that? Because whatever the answer is, you multiply by the coefficient. So the Y value goes up higher now. If A is between 0 and 1, then it's a vertical shrink or a compression. It pushes down. So the stretch pulls apart and the shrink pushes together. So if anything, whatever happens inside the function is horizontal, and it's always opposite of what it says. If it's outside the function, it's vertical, and it is what it is. All right, that does it for chapter 2, pretty much. So please, over the weekend, please do the homework problems. And if you notice here, I gave you a pretty much descriptive, the two symmetries I gave you, that one is pretty straightforward. But the transformation rules, here's by definition what they are, and here are examples I gave along with them. So what I want you to do over the weekend is please do this graph. Please do the graph and just take a picture of it, send it to me via remind. Yeah, today I'll do that as soon as I finish class today. I will scan